Hello students, welcome back to physics class. In today's class, we begin with an important concept in mechanics, that is dynamics, where we learn about force and laws of motion. So in this chapter, we will be discussing or trying to understand how the objects move, stops or tends to move a body. So let us begin with force. So children, what is force? In daily life, you have wondered why whenever we have applied some sort of push or pull, the body or maybe changing its position. Okay, the rest body may be tend to move and the moving body may be stopped. So what are we going to apply is nothing but the force. So whenever we apply the force on a door, the door may be closed. Or if we apply the force on the opposite direction, the door may get open. Suppose if you hold a bucket and try to pull upwards by applying a force, then the bucket moves upwards. And whenever a ball is approaching you and whenever you given some force on it, the direction of the force ball may change. So these are the daily life examples where the force is being applied and some changes are brought into that body, on the non-living body. So remember children, non-living body cannot either move by itself. Some additional force must be adding on it in either to change its shape, size, direction, movement, anything. Okay, position or a moving body to rest. So generally, force is nothing but either the push or pull. So how to define force means the push or pull on an object which tries to move the body or to stop the body or to change the direction of a body is simply defined as a force. So force is an external agency which tries to push or pull or to change the direction of an object. The push or pull form of a body is called as a simply force, and the force is an external agency. Okay children, so this force is again generally classified into many types. Before that, let me explain you the units of this force. Children, we know that force is nothing but SI unit of force. If you wonder, SI unit of force is Newton. SI unit of force is Newton. This was named after the scientist Sir Isaac Newton. Okay, and the unit of force is Newton. And remember that children, the other units of force in SI system is generally kg force, or it can also be written as kg weight. So what is exactly meaning of the kg force or kg weight? Suppose if 1 kg mass is being loaded, if 1 kg mass is lifted upwards, then the amount of acceleration due to gravity acting on 1 kg mass of a given object is called as kg force or kg weight. I repeat, the amount of acceleration due to gravity indicated with the letter G. The accelerator, the earth always tries to pull the body towards itself. Okay, and whenever we apply a force on it, the body is pulled against the gravitation, acceleration due to gravity. So if you consider 1 kg mass, the amount of force acting by an earth's surface, that is acceleration due to gravity or earth's pull or push by an earth's surface, is called as a kg force or kg weight. In simple form, let us try to understand the relation between the kg force or kg weight with respect to Newton. Both are same children. So 1 kg force is nothing but 9.8 Newton. So children, remember, 1 kg force is equals to 9.8 Newton. So this is the SI unit of force. if you would like to talk about the CGS unit of force, then instead of Newton, we will be indicating with dynes. What is that? This in Newton and this is in dynes. Instead of kg force, we will be writing it as gram force. So kg, gram. So kg force or gram force. It can also be written as, instead of kg weight, gram weight. Okay, children. So 1 kg force is equals to 9.8 Newton. So, and 1 kg is nothing but 1000 gram force. So, how much, children? 1 kg force can also be written as 1 kg force is equals to 1 kg can be written as 1000 gram force. Both are same. So, instead of 1 kg, I wrote it as 1000 gram and force common. Or 1 kg weight can also be written as 1000 gram weight. Okay, and based on that, one more thing you need to remember, children. 1 Newton is equals to 10 power 5 dynes. 1 Newton is equals to how much? 10 power 5 dynes. Later examples, I will explain how 1 Newton is equals to 10 power 5 Newton after the proper definition of the Newton. So, laws of motion, we will be defining the what is force. The definition of force will be given properly while explaining the next concept, that is laws of motion. So then I will explain when the formula has been Newton's second law, we will be deriving the formula for that. From that formula, I will try to explain how 1 Newton is equals to 10 power 5 dynes. For the time being, remember 1 Newton is equals to, children, 10 power 5 dynes. So 1 kg force is equals to 1000 grams force and 1 Newton is equals to 10 power 5 Newton. And remember, gram force or kg weight. Kg force or kg weight, gram force or gram weight means the same. So 1 kg force is equals to 9.8 Newton and 1 Newton is equals to 10 power 5 dynes. So try to remember this. So children, the push or pull of an object which tries to move an object or which tries to stop a moving object or which tries to change the direction of a moving object is called as your force. I repeat, the push or pull on object which tries to move a body at rest, which tries to stop a moving body or which tries to change the direction of a moving body is simply defined as your force. Okay, and the SI unit of force is kg force or kg weight, and also Newton, where the relation between kg force and Newton is 1 kg force is equals to 9.8 Newton. And whereas the CGS unit of force is gram force or gram weight or also dynes, where the relation between Newton and dyne is 1 Newton is equals to 10 power 5 dynes. Okay, children. So now let us try to understand clearly regarding the types of forces. Okay, children. So based on the next types of forces, let us try to understand. Okay, children. So what force exactly can do? So what are the main basic parts of force? Okay. So what exactly a force can do? Still far I have explained you what is force and the units of force. So what a force can do? I told you that force can make a moving object to stop or it can make a rest body to move. Okay. So case 1, first case, what is the first case, children? Force can make a body move. Force can make a body move. Okay. Suppose a ball is lying on the floor. A ball is lying on the floor. And if it was hit with a bat, what happens to the ball? The ball will start moving. Isn't it, children? So initially the ball was under rest condition, and when it was hit with a bat, the ball starts motion. So the force can, by applying a force, we can make this ball to move. So force can make a body move. Similarly, while you are holding dumbbells, you know, children, while doing exercises and all, something it will be in this case, okay. So whenever it is lifted up, then, so it was initially the dumbbells was lying under rest condition on the floor, and when it was picked up, the dumbbell will change its position. So that means we can make the dumbbell move. Okay, children. So that means, how does a force helps means, it can help the body to make a move. Suppose while playing a football, when you kick football lying on the floor, the football will make a move. So kicking a football lying on the floor is also an example where the force can make a body move. Case 2, if you consider, force can stop a moving body. Force can stop a moving body. Children, suppose you are playing a football. You are playing a football, and the goalkeeper was trying to stop the football. So whenever the ball is approaching towards the goalkeeper with a lot of force, then what happens? This goalkeeper tries to stop that football approaching him by applying large amount of force. That means this football player, the goalkeeper, can make the moving ball stop by applying a force. So this is an example where the force can stop the moving body. Okay. So goalkeeper can stop a football approaching him by applying a force. Similarly, suppose you are riding a bicycle. While you are riding a bicycle, you apply the brakes suddenly. What happens to the bicycle? The bicycle stops. Okay, so because of the application of brakes, because of the application of force on brakes, what happens? We can stop the bicycle. So these two examples, the goalkeeper can stop the football, whereas the brakes, the force applied on the brakes can stop the bicycle, is an example where the force can stop a moving body. Okay, and coming to the third example. The same bicycle, if you consider, the person is slowly, small children, you know, slowly they are trying to pedal the bicycle. When they are trying to pedal the bicycle slowly, what happens means their parents or the siblings may give some kick on his bicycle, so that when they will be hitting it a little harder, then the bicycle may move with a larger speed. And similarly, if a bicycle is moving with large speed and you apply an opposing force on the bicycle may you can decrease the speed of the bicycle. The same bicycle, we can either increase the speed of the bicycle by giving a forward push, or we can stop the moving bicycle by giving the backward push. Okay, that means before it stops, we are decreasing its speed. So either the speed can be increased by giving the supporting force, okay, or the speed can be decreased by giving the opposing force. So either you can increase or decrease the speed of the bicycle, increase or decrease the speed of the bicycle, speed of the object, by the application of force. So the force can make a body to move. The force can either stop a moving body, or force can either increase or decrease the speed of a body, increase or decrease the speed of a body. What else the force can do, children? The force can also change the direction of a moving body. introduction part, I already told you that suppose if a ball is approaching towards you and whenever you hit the ball with a bat, then you can make the body or ball to move in the other direction. That means the ball is moving in this direction, and if you start hitting the ball, you can make the ball to move in the other direction. That means you can change the direction of a moving ball by the application of force. Not only this, children, even while playing the carom board, because of the application of the force, you can make a ball, carom coin, to move in any direction possible, any possible direction by the application of force based on the direction of the force that is being given. So fourth case, what force can do is, force can change the direction of a moving body. Force can change the direction of a body. It may be moving body or the rest body, whatever be that, force can change the direction of a body. So what is the first case, children? Force can make a body to move. Force can make the body to stop. Force can increase or decrease the speed of a body. Force can change the direction of a body. Not only this, even the force can change the shape and size of a body. For example, if you consider a small rubber band and if you try pulling it harder, rubber band, if it is stretched harder, then the shape of the rubber band is being changed. That means its length may increase and the thickness may be decreased. Stretching a rubber band, okay, the shape of the rubber band can be changed by stretching it by the application of force. Not only this, even if you consider a spring, the length of the spring can be increased or decreased by applying the force on the spring. Not only, children, if you consider the toothpaste shape, initially it was inside the paste, means it will be something like broader size, and if you squeeze it, the shape of the toothpaste can be changed by the application of force. That means, so force can, next way is, force can change the shape and size of the body. Force can change the shape and size of the body. Shape and size. Even one more thing, force can also make the body rotate. Force can also helps the body to rotate. Force helps in rotation of a body. Rotating a body. Whenever you switch on the electric current, the fan starts rotating. When you switch off the button, then the fan may stops. If you apply some force on a fan, then the fan will start rotating. If you apply opposing force on a rotating fan, the fan can stop. That means this application of force can also help you rotate a body, rotating a fan. Okay. Similarly, the earlier case I told you, to close a door, you apply a pushing force, and to open a door, you will be applying a pulling force. Okay. That means the door will be rotating by the application of forces. Okay. So force will help us in rotating a body. Maybe the blades of the fan can be rotated by the application of force, and the door can be opened or closed by the application of force. So what are the main what a force can do, children? Force can stop a moving body. Force can make a body to move. Force can either increase or decrease the speed of the body. Force can change the direction of a body. Force can change the shape and size of the body, whereas force can also help in rotating a body. So these are the main application of forces, children. Okay, so based on that, let us try to solve few numericals based on this force. So first, moving ahead. So worksheet number 1, first question, single correct answer type. First one, the SI unit of force. What is the SI unit of force, children? It might be kg force, kg weight, or Newton. So what is given? Newton is your right answer. So here goes your answer, Newton. Okay, where 1 Newton is equals to 10 power 5 dynes. Moving ahead, question number 2. How many dynes are equals to 1 Newton? Children, I told you that 1 Newton, how many dynes are there? 1 Newton is equals to 10 power 5 dynes. 1 Newton equals to 10 power 5 dynes. So, option number C. Moving the next question, a force can. Just now I told you, what a force can do? 6 cases I told you. Force can make a body move, force can make a body stop, force can change the direction of a body, force can increase or decreasing the speed of a body, force can rotate a body, force can change the shape and size of a body. What is given? Yes, it can change the direction of a moving body, it can change the state of rest or motion. So, it can make the rest body to move or moving body to stop. So, change the state of the rest or uniform motion of a body. It can also change the shape of a body. So, what is the correct answer, children? All the 3 are true. Hence, your correct answer is 4th one, that is all the above. Okay. So, it can make a body to move. It can stop a moving body. It can change the direction of a moving body. It can also change the shape and size of a body. Moving ahead, a force has, one more thing, children. Force means some quantity it has, some amount of force is being applied to make a body move or stop or direction, whatever it is. So, some magnitude is there for the force. Even we have just now considered that direction is there. Force is having both magnitude as well as direction. So, whenever a physical quantity has both magnitude and direction, definitely it is a scalar or vector. Yes, it is a vector quantity. Remember, force is a vector quantity because it has both magnitude as well as direction. So, force has both magnitude, direction, yes, both it has. So, what is the correct option? Both magnitude and direction. So, which correct option? Option number C is the correct. That is, force is a vector quantity, so it has both magnitude and direction. Next question, when a force is applied on a moving body, it may change its. What can be changed? So, 6 cases I told you. Can it change the speed? Yes, of course it can change the speed. Can it change the direction? Yes, of course it can change the direction. Both speed and direction? Of course it is possible. Okay. So, none of them are no. So, which one is the correct answer? It can change both speed, increase the speed, decrease the speed, change the direction. Any possibilities are there. So, force can, whenever a force is applied on a moving body, it can change its speed as well as its direction. So, third option. Next, the relation between the SI unit of force and the weight of a 1 kg mass is, you are asked to find out SI unit. How much I told you, children? 1 kg force is equals to how much I told? 9.8 Newton, because 9.8 is the gravity, acceleration due to gravity acting on a mass of 1 kg. So, how much acceleration due to gravity acts in SI system? 9.8 Newton. So, 1 kg force is nothing but the 9.8 Newtons. How much? Where is that, children? 1 kg force. Yeah, this one is the right option. So, 1 kg force is not equals to 1 Newton, it is equals to 9.8 Newton, because acceleration due to gravity acting on a 1 kg mass is simply defined as your force, and how much acceleration due to gravity in SI system? 9.8 meter per second square. So, third option. 1 dyne is equals to, so how much is the 1 dyne is equals to, children? Let us try to calculate. Yes, sir. 1 dyne is nothing but 10 power minus 5 newtons. Yes or no, children? Because 1 Newton is 10 power 5 dyne. So, 1 dyne must be equals to 10 power minus 5 Newton. But here you need to convert in gram weight. And also we know that 1 kg weight is equals to 9.8 Newtons. 1 kg weight is 9.8 Newtons and 1 dyne is equals to 10 power minus 5 Newtons. So, better instead of this, whatever you know, let us write the same thing. 1 Newton is equals to 10 power 5 dynes. This is what I have already told you. So, instead of 1 Newton, I can replace it with 10 power 5 dynes. So, 1 kg weight and also 1 kg weight equals to 9.8 Newton. So, 1 kg weight can be written as 9.8 into, instead of Newton, what you will be writing? 10 power 5 dyne. Very good. But what you're asked in terms of dynes, you got the answer. But here either kg weight is there and gram weight is also there. So children, if 1 kg weight is 9.8 into 10 power 5 dynes, then how much 1 dyne equals to in kg weight? It must be 1 by 9.8 into 10 power 5. But here it's not. So gram weight is also there. Let us go look for that. So kg weight can also be written as 1000 gram weight. I told you children, 1 kg is written as 1000 grams. So 1000 gram weight is equals to 9.8 into 10 power 5 dyne. Any doubt children? So clearly 1 Newton is 10 power 5 dyne and 1 kg weight is 9.8 Newton. This was already told to you. These two cases are known earlier. So 1 kg weight equals to 9.8 into, instead of Newton, I wrote it as 10 power 5 dynes. And instead of kg weight, I wrote it as 1000 gram weight. Now you got the relation in gram weights as well as dynes. So 1 dyne is how much? So here 1 dyne can also be written as, bring this numerical value the other side. How much it will be? 1000. 1000 means, yeah, I'll keep it as it is, gram weight by, bring this value numerator, denominator 9.8 into 10 power 5 is nothing but 1, 2, 3, 4, 5 zeros. These 3 zeros gets cancelled. 9.8 into 100, how much children? 9.8 into 100 is 980. Hence, what is the correct option we have? So 1 dyne is equals to 1 by 980 gram weight. So clearly, how much is that? Let me write it here. Here what is left children? 1 gram weight upon 9.8 into 100 is 980 is equals to 1 dyne. Therefore, 1 dyne is equals to 1 by 980 gram weight. So, second option is true. 1 dyne is equals to 1 by 980 gram weight. For 7th one, option B is true. Okay. So, moving to the next question. Yes, children. So, this, let us wind up the concept of force from this question only. Next, in the next class, we shall move to the laws of motion. Okay, children. So, thank you and prepare well.